testing. Okay. Let's keep an eye on the chat. Right, back from the last stream. I can swap the first and second base class, but is that sufficient? Yeah. I don't like this at all. We have a pointer to the tracker. The tracker is not initialized yet. I'm doing all kinds of stuff with it. That might even work, but not sure. I can imagine that it doesn't actually. How about I add an assert for access to trackers? Anything when the tracker's not initialized yet, because now it's very unclear. Please somebody turn this obscure bug into an assert. Well, not really though. Yeah, well, that's the problem of the not initialized tracker, also a not initialized mutex object. Lots of stuff that is not initialized yet. That kind of screws up yeah, inheritance, however, right? At some point you set it and then you derive from that class. Oops. Let's see if we can work this. No, actually assert is defined when this is defined, or set. So I should be using that if I use it in assert. I guess every member function needs to test it then. This might be part of the initialization itself, now I think about it. Set tracked unlocked. Now we are locking this member here, so it must be initialized. Right, so after that it should definitely crash very quickly. Like here. Yeah, the first call is apparently to the tracked what. And we do that from that's from the constructor of lock node, which is the base class of our unlocked. So that is completely correct that it crashes here. I think this is already the exact point where we had a bug. Even though I don't set it yet, it should of course crash anyway, because that was the bug, that bug exists. But let me set it, let me set that new boolean. Oh, I'm lost. Oh, it was you. Base class with the item tracker. So I think I don't derive from GraphTracker. I hope not. Nah, it seems very unlikely, but let's check. GraphTracker. Grab sources, public graph tracker. Does it look like it? Maybe with some namespace. So not. Yeah, I don't have private or anything, but no. So that should work. If we just set it here in the most, as if this is the most derived class. Oops. Now I say that, so let's make sure that this is the most derived class. Adding final, now I cannot even derive from it anymore. Now you have to do the same thing for, well, I think the only other tracker that I have is the node tracker. That needs the same thing. I should have included it. Terminate. Wait a minute. I'm gonna close this top. These guys never have good music anymore. I'll have to really make my own database of music, I think. Getting a bit sick of this directory. Always the same music. Well, that's disappointing. That's the same error. So the assert is not asserting. What? Okay. Okay. Yeah. So one thing was the tracker, and the other thing is the mutex itself. So apparently we did not use an uninitialized tracker. Maybe I was just wrong. But we are using an uninitialized mutex here. And the reason is that I'm using a tracker still to get to the mutex. This kind of gives away that it is a tracker, but hey, Pose Bunny. Of course, we have control over which mutex we're using. Excuse me. In fact, I'm already switching mutexes. Like without debugging, I'm using a standard mutex, and with debugging on, we use AI mutex. So you could extend AI mutex to complain if you try to lock it without having it having the constructor being called already. That would work. But do I want that? maybe the problem goes a little bit deeper. I think it's not really the mutex. It's more like the no. It's more like the second base class. Like it's still part. The second base class of unlocked. Sorry, I'm not finishing my sentences. Which is still in Git submodule threadsafe, not in this project. So, we want to do this in the project, add debug code in the project instead of adding it to the existing threadsafe, although that's existing between quotes, but I wrote it like last week. I worked at least a lot on it. I don't want to blame threadsafe. I think nah. Where am I in anyway? Which file is this? Ooh, we are, maybe it is the problem of threadsafe itself. Yeah, so the access cons here has a unlocked pointer that points to a partially uninitialized object. Which means that I just should not have tried to lock it. Right, so maybe go up, think about this one. Well, that's just a constructor of access cons access. So here it is then. Problem is that points to a partially initialized object. I could add it to the unlocked base tracked object, I think. This is just a cons class, so this is an unlocked base tracked object, cons reference, this thing here. Or a pointer actually, and then we dereference it there. And the current object is initialized, therefore this one is initialized and we can lock it. And then we get this pointer, but this pointer then points to a not yet initialized object, and we have to check that too. Now I added this assert anyway, I might as well add a second assert, right? To check that it's that this one is pointing to something that was already initialized. Yeah, how to do that? I was thinking about if I don't need a magic number here, because a single bit here is a bit small. Could of course have this whole object being not initialized, like completely not initialized, not partially, but absolutely not at all. And then even this boolean would have a random value, so then we have a 50% chance that it doesn't assert while it should. Is that even possible, however? In the end, we are calling tracked what on it. So we do have an object that we can call it on. It is the case with the mutex. That is 100% not initialized. So I can definitely not use a boolean inside of that. So why does the boolean work here then? That's what I'm thinking about. Tracker. This is the highest base class of every tracker. And trackers are created with a standard make shared. So then I think that's like the first thing that it does is set this boolean to false before anything else, and before the call to standard make shared. Yeah, there's no object. I cannot really not believe that we would access a pointer to the tracker if we didn't even call the make shared object, right? Make shared pointer or whatever it's called. I think this boolean here works, and I'm starting to doubt now if this is ever a problem. It was a problem before. Yeah. Yeah. Dereferencing that pointer. The tracked unlocked pointer here points to this nested class. Which is that is bloody another wrapped in another unlocked, and then a member of ObjectTracker. and that is already initialized, right? I'm slightly confused here. All right, so yeah. This is already initialized, but the thing that it points to isn't. So we're passing something here that is a pointer to something that is not initialized. So it looks like a reference, but in the end we just store a pointer to it. And it points to something that wasn't initialized yet. Or only partially. I forgot. I looked at it yesterday. Yeah, no idea. So, I don't know. What shall we do? Doesn't it come down to that I want to check if this thing has pointer in its name, but isn't a pointer? Or is it? No, it's not a pointer. Well, it's the reference here, but it's an access type. Let's just add some made up function here. Using a dot doesn't make any sense, and we just have the red. So I dereference it, that should work, and then it's pointing, it's returning a pointer. And that, I would like to know which type that is. So this is going to say that this function does not exist. And then at least you know which type it is, because I have currently no idea. If I had perfect memory and stuff, well, okay, but I'm sorry. No member name debug in ObjectTracker of unlocked tracked object of locked graph. So that's the type. This is the type of whatever that thing is pointing to. That is a tracker. Could it be a different object tracker then? I'm very confused. Well, I don't know why, but it's a tracker, so yeah. In that case, we can call the function that we already have. So this one was true, but apparently this is maybe a different object. So I can add just right here a public pool. Debug is initialized. Yeah, I'm pretty convinced that actually where we are, no, that doesn't make any sense. Shit. Now what? No member name debug is initialized in threadsafe ObjectTracker something. Oh, okay. colon, that's a bloody nested class of the ObjectTracker. Well, this is the type, which is a nested class. So it started with the class that it is nested inside of. Whoopsie, okay, so that was not correct then. Let's not do this. No, we're trying to check if this object here, this class, is initialized. which includes an unlocked base, which is a tracker which has all those pointers, which I think point to existing objects which are not initialized. Excuse me. And itself, it is probably initialized. So yeah, this is still not good enough, but I'll add it. Return stuff. Because this is the one that it is calling, right? I mean, I'm just testing if it compiles now. Yeah, that was the one. And then we want to do the same thing. Well, I can just use unlock base then, right? To add everything to. But then you have the problem that, you know, I don't want to repeat all the constructors of unlock base. So this using is nice. And if I need one constructor here just to set that boolean, then I have to repeat all those constructors. And if I don't do that, then this constructor has to set the boolean at the end, which means I cannot derive from it anymore, at least not in a way that still needs more initialization. Now, how many constructors does unlock base have? 1, 2. That didn't work. Loads and loads. This is assignment, but it does have a default constructor. Yeah, I would have to repeat all those stuff. Well, it's a copy constructor and it's not a default constructor. It's a copy constructor and a move constructor. And then this one. And another one here. This one is only for unlocked cast. It's private. So probably don't need to repeat that one. I'm wondering if I have to. Seems unlikely I have to re-implement a copy and move constructor. I mean, I'm copying and moving, I'm guessing something that is already initialized. I should check that though. Oh yeah, right. That would be horrible. I have to check that I'm not copying something that is not initialized if I want to go this route. The whole thing of working with not yet initialized objects is just wrong, right? Shouldn't be doing that. This happens purely because I'm inclined to assume that it will just crash if we use anything that's not initialized yet. And then maybe just take a shortcut and just test if it crashes or not. And if it doesn't crash, assume that it works. Yeah, I think I'm going to do that. Test the work. I have to finish this at some point. Oh, that's kind of... And then let me remove this again. Okay, so then I'm just going to swap these base classes. While I'm at it, I might as well move this one up. So now the policy mutex is kind of standalone thing, so I can initialize that, and this one as well. And then we create the user provided type, which might or might not access the policy mutex already. And apparently it does in my case. I'll add a comment, I guess. Now, how is that even possible? How is it possible that during the construction of this base class here, we would access that base class? The reason is that, and I hope I can finish that sentence, the constructor of unlocked here constructs the T from arguments that are being passed to it. Really? Yep. So we are passing arguments to it that are already pointing to the completely not initialized base class. I mean, even before constructing the thing itself. Is that even possible? That's a deadlock detection. Trying to lock something that's already locked by the same thread. Yeah. While printing, whatever we are printing here. L minus. Printing a shared pointer to a tracker. Well, the tracker is already locked. And then inside it locks it again, apparently. To print the content of it, of the tracker. Why are we doing that? Up. Tracker. And that's from the printing a weak tracker. Okay, up. That's while printing the parent graph tracker, which is then a weak pointer to a graph tracker, which apparently is already locked. At the moment we do the set parent graph tracker. And then this one is already locked. It's not that one. Sorry, set parent graph tracker calls this one. Yeah, so this one points to a tracker that is already locked. Where does the tracker come from? Oh, it is just a member of the locked graph. Add node. No. I would say that happens here. I think it happens here. Can I reproduce this by locking on breakpoint 22, run that, we reach 22, and now I do continue, Yeah, so we get a 22 only once. And at this point, I would like to set a watch point on the mutex that is doubly locked, so I do have to do a continue. Up, 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 up. So here we see MID, this current object has an ID set for with the current thread. I can also use that, or the owner. I think the owner is best. I'm going to use the owner, so try to print that. Print mutex dot owner. Oops, or not. Mutex, of course. There's lots more. Data dot owner. Yep, there we are. And then all that is an int, so I can set a watch point on the stack even. The pointer. Watch that address, but I don't want to do that already, I think. Copy. No, let's rerun again from the beginning. Now that thing here, done without watch, should be have no owner, so that's 0. That looks good. Oh, let's just set a watch point. Those addresses repeat all the time. Continue. So yeah, then I'd set the owner is set. That was the same owner, I guess, or well, maybe not. This is the current thread anyway. Yeah, that's the current thread. That the LWP changed. So this is where it is locked. Now we have to figure out where that is. That's, well, here. But it's inside a call to the lock on the AI mutex. And which is here. During the construction of an access const. Okay, I just have to go up further. To here. That here we are creating an override access type. And that is a call to track what? And let's go up again then. So yes, I was right. So we had a breakpoint here, and this is logging whatever we try to log again then inside add node. I suppose I have to extend add node so I can pass the locked, sorry, I can pass the access type of the current object that I'm calling add node on. That doesn't make any sense, of course. That would be just this pointer. I don't need an access type, in my opinion. Once I have it. Is it really just what I'm looking here is, yeah, whatever the object is being returned as a pointer to this, right? So that is the this object. The this pointer points to the object that is just logged. I'm going to delete all the breakpoints and then break at 23 and then step through it. Let's see if we can follow this. Okay, the parent graph tracker is a standard weak pointer. To a graph tracker, and then this is the graph tracker. Let's highlight that. And then create a standard set pointer that points to that from it. And then we can access the track what on it. So we're going to call the track what on, well, create set pointer, increment the reference count. Why do those, the standard library is always so much lines and calls? It's got no end to it. Okay, so yes, now we are inside track what, and this pointer is highlighted. So now we're inside this function here. That this pointer is the graph tracker. And what they do inside of the graph tracker is lock the tracked unlocked pointer. Get a read lock on that. So this is the graph tracker. And the first element is the tracked unlock pointer, which we're now going to lock. So if we just print that part, it's most of it. So now I have a read access type that has a pointer to what we can access, and that happens to be the highlighted thing. What? Yeah, so that is a reference to the same object. It doesn't bloody print it. No, it prints these things. So these. No, it is a reference. Sorry, it's a reference. Save all log base. All right. Checked on the pointer. Okay. It's still hard to wrap my head around it. I think I'm just I've become too stupid for this. Seriously. I did manage to write it, but then a few days later I'm like stumped with what I did, and it's still not working. Try to go back to that one line. This one. So the tracked what here works, and that returns a what, and I was realizing that the best way to work that is auto at some point. And then, yeah, what is the name of that thing? Parent graph tracker, track what? Don't even know what that is. Parent graph tracker is a shared pointer to the graph tracker. So we're talking about a graph tracker here. We call tracked what on the graph tracker, or on any tracker, and that then returns an access object so we can write to accessing what with an H. this what? To unlocking, accessing the unlocked type, which is this. That is an unlocked base of track locked type policy type. Where track locked type is this thing. It is absolutely not followable. What the hell? That's why I can't follow this code. It's just using abstract types all over the place, and maybe they're just named wrong. Too many locks and unlocks and tracks and stuff. I think that this returns an access type to what the tracker points to, right? Parent graph tracker should be a tracker of a parent graph. So I'm pretty sure that this returns a write access type to a graph. Let's try to make sure that that is the case. See if this compiles. So I split that one line up in 3 lines, so you see a little bit better what's happening then. So we have a, well, actually it's the parent graph then. Parent graph. So you have a tracker to the parent graph. I right lock it, which gives me an object that, because of its existence, proves that the mutex is locked. And I can use a dereference a star on it or an arrow to actually access the underlying type. For example, I can do a star and then we get the type as a non-const reference because it's a right lock. And this then is the parent graph. And then as a reference, so I can do dot add node. Shit. Non-const L value reference to type. Graph is graph. Cannot bind to a value of unrelated type. Oh no, we do get a locked graph. No, that makes sense. I mean, we just locked it, so we get a locked graph. Yes. And now we call add node on it, and we can only call add node on it because it's locked. Should not be able to call add node when it's not locked. Like literally, lock graph add node. And then you convert the weak node tracker that is being passed, and which we are going to add to a shared pointer, and if it exists still, then we try to add it to the current graph. On this line temporarily locks, right locks the dot graph, so that's hardly not really super interesting. It's the graph is dot stuff, and this adds it to the node trackers of the current graph. So that's the add node thing. And this line blocks. What is it trying to do? We just added tracker. No, we didn't. We just added weak node tracker to the current locked graph. And weak node tracker was converted to a node tracker, so shared pointer. So we're right locking the node that we just added, and then we say that is now your parent graph, because you were just added to it. But note that we cannot pass this pointer. I mean, it was just added to this object. But this object might be moved in memory, and we want to only store pointers to it that go through a tracker. So instead of storing a pointer to the locked graph, we are storing as the parent graph a tracker. So we say, okay, this node was added, and we know that we use the tracker. We always use trackers as pointers. We have to lock it, so it's not being the tracker points to an object that might be moved, but at the moment we lock it, it's not any longer possible to move it. So okay, now we have full access to the underlying object that the tracker is pointing to. And now we say your parent graph is now the object that this tracker is pointing to. Totally makes sense, totally makes sense. We then just should store that tracker. And it doesn't move to parent graph tracker. And this is what goes wrong, because it's just debug code, but it tries to print the contents of parent graph tracker. And in doing so, it's going to try to lock it again, while it is already locked. How about I just delete this line, get it over with. There, bug fixed. Everything else looked fine to me. Or not, still deadlock. Hopefully we do get further though. I'm not convinced though. Hmm. Okay, again trying to lock something that is already locked. Okay, this time it's here, which is a different place. That's not deeper code, so you cannot just delete a line. Yep, so really trying to right lock this thing here. That's blocking because apparently no tracker is already locked. And that is coming from there, coming from there. It's already locked while it's part of a vector. Ouch. I mean by the same thread even. Well, let's do the same trick as before. You have to go up far enough that it is not locked, but then I can just use a watch point to see where it did get locked. But then I need an address to go down. That should go down all the way to the mutex. Put this. Let's try the owner. Use the owner again. Can print a mutex dot data dot owner, and then put an ampersand in front of it, and now you have the address, which currently is that value, of course. And now I want to go up until I think it is no longer locked. Oh, that's in the right dot. You gotta be kidding me. This might be the one. So could it be graph itself? That is the last line though. It's a very short program, but hey, we make progress. Yeah, well the only G1 is locked here. So there has to be G1, right? So I can set a breakpoint on on line 23. That should stop before we lock it. Run it again, and now we print that value, and then, oops, no. This was the address, so. It's already locked. It's already locked. What the hell? How is that possible? I just keep something locked, I think. Which is... No, I don't. What? I guess I'll just set a breakpoint here. Maybe I'm forgetting to unlock something. Peculiar. It's line 12. Break 12. Run. Yes. Delete one. No, I don't care. Well, that looks pretty uninitialized, but we can work with that. So let's do a watch of this address and then continue. Now it's set to 0, so this is where we created it and initialized it, and then, well, that's apparently G0. Or is it printing that, but we are constructing N0? Maybe it's N0. It's a label node. Yep, it's N0. Or is it? The address of G0 is that, and the address of N0 is that. And the address that we are watching is D488. Oh, that's like totally an N0. Yeah, well, I swapped the base classes, so now the mutex is the first one. Well, that's confusing. That's confusing. I would say that N0 is locked here temporarily, but definitely should be unlocked before we get there. Or here. So maybe there's a bug here that it locks N0 when copying it, but doesn't unlock it again. Continue. Yep, now it's locked. And that's in... add node. The add node that happens is a result of construction. Okay, it has to be locked while we're adding it. So you do continue, but it's going to be unlocked again. Yeah, now it's unlocked. We should still be constructing it. That's still on that line. So now I'm going to do continue again, and now we see that it is logged again, and well, still that line. It's logged again. Why? That's in do read log. Let's go to frame 5. Oh, I forgot to unlock it, like literally. This one is doing do read log, and then in the body you must unlock it. So that's the best, well, plain fat bug. Ooh, big bug. We're done, so we unlock it again. Exited normally. Yeah, I guess it works then. Do I still have a history here? History, grab the big view. Nope, we're on our own to type that in again, unless maybe I have it here. Yes, we have it here. Okay, and I was talking about what? Label node test. Label node test, the magic. No, okay, that's our label. 2 nodes with labels in it. So impressive. Dot source. Let's see if the other ones are still made and working. Hello world. I haven't printed that one for a long time ish. Well, printed, I mean drawn, the graph of it. Nice colors, look good, works. That's the last one, so not try this one. I don't think it exists actually. Yeah. PI. Let's go to source. The next one. What? What? No, no compile errors. You gotta be kidding me. Next thing you're gonna tell me that it just works immediately. Index container set test. Yeah, no problem. That just works. Right, okay, so then we have the last one. Now that's a tough one, I think. That's never going to compile immediately. Nope. More work to do. Okay, almost at the end, like literally the last line. The rest is compiling. Wow. Shocking. Maybe I should make this compile even. What is G0? It's just graph. Why not? I can just do that, I think. So I don't have any read access types or write access types at all in the whole file. That's what I like. That's super nice, yes. That would be very nice. Making thread safe without having to change the user code. So we compare this one with, let's say, that one. And then we see how I can fix this. Well, I had to read log it here. But why not add a write log to graph and then do it for us? Oh, because it is That is an unlocked tracked object. Oh wait, I have, yeah, no. I would have to make it a derived class then. Unlocked tracked object is not final. Let's read what I wrote. Ooh. Wait a minute. Oh, well, that's between parentheses. Yeah. So move constructor tracking support if this between parentheses final, but it's not called final here anymore, is moved and first. Oh, that's doing the do right look. Yeah. Okay. Cool. It's totally supporting. Deriving from it. So here, move constructor can be used for from a derived class, which then has to do the locking. So we can use that and then make a graph derived from it, and then add a right dot to that. Maybe I want to do that. I think I want to do that. Do I want to do that? Yes, I want to do that. Oh well, yeah. Well, yeah. No, not 100% sure, but maybe I should. I'm going to change this, but then it doesn't compile, and I want to commit it. Oh, who cares? So in the end, I want this to work. Let's commit what I have now, though. Utils, git status, git dev. Just rename of T to U. Commit. It's still very painful, this one. I would really love to be able to put this in the same file as the ObjectTracker.h. But it's not possible because then we have to include headers that we just don't even know about. User headers. It's not possible. And it's the tracker that is the problem. The tracker is tracker second argument. Okay, so I'll add a comment here. So the second template parameter tracker is incomplete while well, processing, compiling, I don't know. While processing the header. And is in this file access tracker. Yeah, see, there's the problem. It's just very unclear. Probably every CXX file that includes ObjectTracker.h, right? Yeah, that seems logical. That includes ObjectTracker.h directly or indirectly. Well, I guess I should find out which one those are. And they should be included at the end, I guess, also. So this should not be needed, because if I only have to include this inline.h in every compilation unit that already included ObjectTracker, otherwise directly or indirectly, right? Yep, let's do this differently. So we have ObjectTracker. I'm going to add if not defined threadsafe ObjectTracker h. Define. I have something in my head. That's what I had. Yeah. How can you copy that again? That's at the end. And if but yeah, no, I have the right dot problem. It didn't fix it. ObjectTracker.h. Nothing. No, of course nothing. Why is this including that actually? I'll just delete it. I should make a different header for this one, I guess. Tracked object is defined in the same header now as object tracker. Yeah, this is just asking for confusion. The inline code. Oh my god, what am I doing here? Object tracker inline. This is about tracked objects. Tracked object, tracked object, tracked object. So it belongs in tracked object. I'm going to rename it. Move tracked object. How the hell did I not first commit this? Idiot. Unlock tracked objects. Is it not possible? Yes, it isn't. Tracked objects. Okay, so we keep this, and then do I not have to keep the other one? This one. I don't think so. Oh, shit. No, don't tell me. the hell? That's not the one I was looking for. Hmm? Hmm. Hello, dreaming warlord. I think I'm having two headers here, so I can probably do just this, which I was doing. Just include it before you close it. I'm having two headers here actually. Yeah, I'll leave the harder one. I cannot include item tracker here. I have to do that at the bottom, right? Because this is item, not item tracker. What? I need an AI to solve this for me. I don't want to think about it. Yep, include graph, then only one graph. Getting so sick of this. I think I'm going to cook dinner. Okay, warlords, yeah. Circular header dependencies are really real big pain in the ass. Real big pain in the ass. Oh yeah, the problem is graph tracker depends on graph, or does it? Not if you can just forward declare it. But then again, graph is not forward declarable. Or rather, the problem is that graph includes item.h. Is that necessary? Oh, probably is. No, or not. It's only using item template. Item. Let's try including item template then maybe. Oh wait, that's defined in item.h. Yeah, okay. Item template is derived from item, so might as well put that here. So then we definitely need item to be included because we define log graph. But the only thing I need is graph, not log graph. So maybe I should make a separate head of a log graph and then a separate head of a graph. I don't know what to do. I'm getting so sick of this.